Hello, in this video I will talk about the vertical curves, all the elements of the curves, or how to find out the different formula that you need to use for found the elevation of the curve. And for this point over here is the beginning of the vertical curve, is the first point, and the other point that you need to know is the PVI, which is the point of intersection of the two slopes of this vertical curve, and G2 also is the another slope going down. So the difference between the two slopes is determined by G2 minus G1. This is the end of the vertical curve, and L denote the longitudinal or the length of the vertical curve. E is equal the distance between the curve and the PVI, and they call offset distance, and call E for the point from here to here. And the first formulas that I'm going to show you are based on this drawing. They call the crest curve. In this case, this is the crest curve, and also the vertical curve with a sag curve, which is this going down, and this is going up the slopes. And another thing that you need to know is that in most cases the curve start at the axis of the this curve start at the beginning of the vertical curve. So the first formula that and you need to know is the difference on the slope, and that's called G. And G is equal to G1 minus, G2 minus G1. So this will be my first equation, which is the difference in a slope between G1 and G2. And usually they give you an percent. The other the other equation that you need to know is how to find out E, and the distance or the offset between the vertical curve and PVI they call E, and this equal to the difference of the slopes times the length of the curve divided by 8. This is my second equation. The third equation is the offset of any point around the length of the curve. And the offset, which is the offset the distance, sorry, that's not 5. The offset is the distance between the slope and the curve. And any distance from the curve to any slope called the offset, and is determined by this formula. Offset set is equal to E times the square of the distance by definition divided by L divided by 2 square. This offset is the distance from the curve to the slope everywhere, for the general determination of the offset, or the distance between the curve and the slopes. And another formula that also you need to know is how to find out from the beginning of the curve to the end the high point of your curve or the low point if this is a curve. And this distance from the beginning of the curve to the low or high point, for here L or high point, will be equal to minus G1 times L divided by G. So this is my third formula. and this is my formula. I don't see any other formula that you can need to know. And when you give examples, you will understand better this. And this equation over here is coming from the equation that give you the general question for a parabola. This, if you go back to your calculus, this is the general equation for find a parabola. It's ax squared plus bx plus c. From here you can find your distance, this x from the beginning of the curve, the distance from the low high point. And if you put your axis at the beginning of the vertical curve, this is 0 and b is g1. That's when you put your original over here, your x and y origin. And if you want to know this distance from the low high point, you derivative this g and equal to 0, you find this. So I'm going to very quickly do it to you. So the g prime, or the first derivative of this equation is equal to slope. So you find out g prime is equal to 2x plus g1. And if you want to find out the high or low point, you equal this equation to 0. And when g prime is equal to 0, you find the distance from the beginning of the curve to the low or high point. So I'm going to do this quite quickly. This is equal to 0, and then 2a x minus g1 x equal to 0, 2a x is equal to minus g1, and x, the distance from the beginning of the curve to the low or high point, is equal to minus g1 divided to 2a. By definition, 2a is the rate of the slope, and is equal to g divided by L. You change this over here, g1 divided by g divided by L, and this is equal to minus g. What I'm going to do here, g1 times L times g, and this is my formula. And you can find all moments with this. Just change this to, this is a is equal to, to a is equal to g divided by L. This is g1, and so on. But this way that I show you, they call the offset distance, which is all the distance between the curve and the slope. Any point from the curve over here to here, from this to here, is the offset distance, and there is that you wanted to find out. And also, if you have this slope g1 and you have this distance x, you have the distance x. You want to know any y, so you just multiply g1 times x, and you find your distance from the slope to this, and this is the slope, and this is the horizontal distance, and then you multiply this by x, and you find the change of rates of the slope, and you add either to the beginning of the curve elevation or subtracts to the beginning the PTI, and you find the elevation. So I'm going to call this my 6th elevation, but I'm going to explain you all of this in a better and to understanding and short example. I will explain you how to use all of this. But for now, I was just showing you the equation that you will need it, which is D1, G2 minus G1, E is equal to GL divided by 8. The offset is E times x squared divided by L divided by 2 squared. The distance from the high-low point is minus G1 LG, and the slope of any point is G times X. That's all. And I thank you for watching my video, and I see you in the next video. Thank you.